Mr. Michael, how are you doing?
I'm searching for my mute button.
You broke up, but I'm assuming you're good.
I'm searching for my button.
Maybe it's my side that's got broken audio.
I don't know. You can hear me?
Not really.
I hear.
Drew, you try say something if you can.
I can
Testing, mic testing.
You work fine. MCR is broken.
And Warren.
Yeah, I'm also getting packet drops.
Blah, blah, blah.
You're like chopping up really badly, like 60% packet loss type stuff. So who's the thing-to-thing research group?
Must be Carsten.
Ah, that makes sense. The whole WebEx getting stuck on a name issue is always entertaining.
Hi, you can't unmute while you are trying to share something. And sharing something is broken at the moment, so I couldn't unmute. Hello, and I also couldn't hear Michael.
That's a weird failure mode. So how is everybody this morning? Or I guess afternoon or evening, depending on where you are. For me, it's morning.
Hey, good morning, Ren.
You can do a better version than that, Benoit. Hi, Benoit.
I'm so glad to see you, Aaron. You're the
Okay,
highlight of my
That's
day.
better. That's better. I knew you had it in you.
Warren, am I better?
Yes, you're all fixed. Well, at least your
Oh,
audio is fixed. I don't know if you're all better, but
I claim to be at least as sane as my audio.
wow, that's a very high bar you just set.
Audio or audience?
Oof.
Ooh. Ooh. My favorite line adapted from the university days of debating is, Mr. Chair, the code of conduct prevents me from calling the member a.
Hey, hello everybody. I see you already have a good time.
Indeed.
Hello, Thomas. So for the program committee, I just uploaded an Excel spreadsheet in the submission. It contains an analysis of the RFC 3535 requirement, with the content of what we did in the ITF and a status. I don't plan to share this, but I'm going to have a link in the slides for people to review. And this is for the key takeaways of RFC 4545.
Thank you, Benoit.
Hi, hello.
So I'm having second breakfast. And for some reason it says, contains no palm oil. It just makes me wonder then, like, what other things they figured they needed to mention that it doesn't include.
So clearly, Warren, it includes everything but palm oil.
Indeed.
Dog hair.
Yep. I can taste the dog hair. It's actually got a separate extra little
so
thing.
palm
like
oil
palm
is
oil
a
free.
Oh, I love those Nugos. Palm oil is a conflict.
Yeah, I know.
You know, that's why it says that. And Nugo, I love those. They're wonderful, to the point where I would eat them over anything else. And they're also, turns out, they're vegan and kosher and halal. At least Bob Moskovich would eat them.
Yep, vegan and gluten-free and non-GMO. Basically, there's nothing in it anymore.
Made right outside, right next to the 3 Mile Island.
Ah, that explains it. So yeah, it has no palm oil, but it contains large amounts of radiation. Actually, because I
Uranium.
I have in my bag a Geiger counter.
He's going to pull out his Geiger counter.
Or actually, it's a scintillating detector, but does the same thing. So yeah, these ones aren't quite as good as the other.
You can't do that without a Yang module.
Indeed. Huh. It does actually have a slightly higher count than background radiation.
Oh my God, really?
Yep. Background
Okay, but you have
radiation
to. You need a control, Warren.
Counts.
You know,
Just
do you have a box of cereal or something?
Are the slides present?
Yes.
Yes.
I can bring them up again later.
Yep. Noticeably higher than background.
I was kidding. It's not actually next to it. It's, 2 towns over, but.
Well, the whole area, but yeah. And I mean, I'm assuming it's just random, random stuff is higher than background. Pretty much by definition. Almost half of everything will. But it still makes me giggle. The best part of any IETF working group meeting or interim or whatever is I think, the random smack talk before the meeting starts.
Right. So you can leave now that we're actually going to start the meeting in a minute. So on that note, we will give a couple of minutes to wait for everybody to join. It looks like we have a good number of participants actually showing up at this point. But
yay, extra snark time.
Glad to see participation levels for this. It's going to be should be a very good meeting and discussion. So,
do you want us to tend to keep our video on?
It is fine if you want to keep your video on. Presentations will kind of wipe it out, so you probably won't be seen. So it's probably up to you. If you're going to speak and are able to use a video, that is, of course, a good thing.
And other than that, you might want to turn it off just for bandwidth, depending on what your home internet access is like, etc. Mine, for example, does not enjoy having my video on.
Well, everybody has to manage their network and bandwidth.
I see what you did there. Well done.
Speaking of network management.
That's the next era of network management, Warren. I'll show myself out.
That's going to be a fun meeting, I can see.
I'm still seeing a couple of random people joining. Why don't we get started since there are introduction slides? Dhruv, I think you're going to go through the introduction slides, correct?
Yes, I will. Thanks. So welcome everyone. Welcome to the workshop. This is Wes and Dhruv. We are the workshop chairs, and we welcome you to today's workshop. Next slide. Let's quickly see what are the top objectives for this workshop. I think the first item that we have is we want to review. It has been 20 years, more than 20 years since we had our the workshop on a similar topic, and that has led to a lot of changes within the network management space in the IETF as well as in the industry. So it's good for us to have a review of where we are and also identify what were the main barriers of how we imagine the world to come, the impact of that workshop, where it has led, what are the limitations, what are the hurdles that we are currently seeing in network management space. We will also explore what are the new requirements that we sort of missed when we were looking at this. Things have changed. Our networks have changed. How we operate the networks have also changed. So what are the new set of requirements there is? And finally, come up with some recommendations, takeaways that we can provide to the IETF community based on the output of the discussions that we are going to have in the next 3 days. And all the details, you will find it in the data tracker as well. Next slide. Let's go through some of the administrative here. We have a public mailing list, which is NEMOPS interest. So all the discussions that we want to have in the public, we will do it on that mailing list. You are also joined an NEMOPS workshop attendee list, which is limited to people who are attending the workshop today. We had a call for papers, and we received around 20 position papers from around 53 authors. We also received 16 expressions of interest, and those are the people that you are seeing in the workshop today. As it's common for all IAB workshops, we do write a workshop report, which is published as an IAB stream RFC. The discussion about the workshop report will happen on the NEMOPS interest list. So if you have not joined that list, please make sure that you are a part of that NEMOPS interest IAB mailing list as well. This workshop is being recorded. As you can see, the red button on the top, the recording is on. And we will publish those recordings in the data tracker as well. But since this is an IAB workshop, we also have a facility to have some discussion that we would want without the recording, and even having Chatham House rules during that discussion. That is a possibility. Make sure to let us know in advance so that we can stop the recording for that part of the discussion if some discussion needs to be had without it getting public. As it's common in the workshop, we would make sure that you don't speak directly. Please use +Q in the WebEx chat. The session chairs will be monitoring the chat, and based on that queue, they will be calling you. And when they call at that time, please unmute and then ask your questions and provide your comments. We are taking rough notes, and this is the notes page link that you will see. We will use the same notes page for all 3 days of the workshop. Next slide. The main aim of this workshop is so that we can provide some key takeaways, requirements, recommendations, some potential next steps. So to make sure that we are able to collect that properly, what we are doing is we are maintaining another notes page, which you see here, NEMOPS workshop next steps. It has been pre-populated based on what we have read from the position papers, from the surveys that we did, and various operator outreach events that we plan. Note that these are just a list. It doesn't represent the views of the PC or even a consensus among us. That's what we hope, that at the end of this workshop, we are able to come to some sort of agreements. But at this moment, this is just a list of various things that we have seen, program committee has seen based on our various workshop activities. Please contribute to this list, especially if you want that to be captured in the workshop report and taken as a key takeaway. Please help and update this list during the whole discussion that we will have during all 3 days. Next slide. This is how we have broken down the workshop. You are at session 1. We are going to have a set of topics where we will be looking back at the past workshop, what has happened since that workshop, what are the changes that have happened, how our journey has been, and how did we end up where we are here. So that's our aim for today. Tomorrow, we will be looking at what are the set of new problems and new requirements that we see. And on Thursday, we will be looking more future. What are the possible solutions, the recommendations that we can give to the IETF community, and what are the possible next steps for us to take after the workshop. Each of the session will have some initial presentations. These presentations are just as a seed for more open discussions that will be done at the end. So make sure that during the initial presentations, let's limit the discussion only for clarifying questions, and let's have a much broader discussion at the end so that we make sure that we have enough time for questions. We do not want just a series of presentations. We want to have good discussions. So please take care. All the presenters, please respect the time, and as well as anybody who is asking a question, limit your questions to clarifying questions initially, and then we will have an open discussion at the end. Next slide. Now you will see the various topics for each session. We have session chairs for each day. For today, we have Ken and Benoit, who will be the session chairs. Tomorrow, next slide, we have Chen and Med, who are dealing with problems and requirements. And we have some bunch of presentations. And similarly, for the last day, we have Suresh and Mahesh leading the discussion. And finally, we will have the key takeaways and potential next steps discussion at the very end of day 3. And with that, this is the initial workshop introduction. And Wes, would you like to add something? Otherwise, we will pass control to our session chairs.
Yeah, thanks very much, Dhruv. I think that was an exact layout of how we plan on doing things. One just quick note, the last time we did this was 20 years ago. There's 3 or 4 of us, I think, that were actually there at the time, myself included. And our goal, today is to find a future direction, just like as it was back then. Last time we came out with an entirely new direction, right? A complete disruption to a large extent of what we expected in the IETF. We don't necessarily expect this one to be that extreme, but we really should not avoid considering, extensive changes if those might actually be useful. But most importantly, at the end of this, we really do want sort of a positive outcome and a direction to head, not just, chaos at the end. So really do think about where we need to go in order to be able to solve some of the problems that we're going to be hearing about for the next 3 days. So with that, I think we'll turn it over to Kent and Benoit.
Yeah, thanks, Wes. I think Benoit's going to do the presentation, but just quickly for everybody, transitioning between slides is not as easy or fast as it is with Meet Echo. So you saw how long it took me to do that. Just hang with me as I transition between slides.
All right, very good. So let's delve into session 1. So I'm Benoit. You've got Ken driving the slides. So on the next slides, please. So we will have a series of presentation that we're going to review now. As mentioned by Drew, please, there's always like 10 minutes of presentation and 5 of clarifying question. We believe that the most interesting part of this workshop will be the discussion in the end. So we plan to publish the recording, blah, blah, blah. We mentioned that. The +Q in the WebEx chat is how we're going to handle the comments. And I've seen that the workshop notes have been cut and pasted into the chat. So very good. So next slide, please. All right, so as it was mentioned, we're going to focus today on the past, look back and analysis, right? So we are engineers, we are solution driven, we don't look in the past. However, if we want to understand the present, we must see the past. And if we want to foresee the future, we must see the past. It's exactly what we're going to do in this session, review the outcomes and the result of the 2002 workshop, deployment state of the art, and identify any operational barriers that prevent these technologies from being widely implemented. So after the series of presentation, we're going to share the last link at the bottom where we start to have like key takeaways. There is first key takeaways on the RFC 3545. Right, it lists a series of requirements. I just posted in collaboration with many others an Excel spreadsheet that contains some technology that we've been doing in the IETF to fulfill the needs of those requirements. There is like an entry for the state of the art, what are the lessons learned, and the current deployments, what works, what doesn't work. Based on the presentation, we started to pre-populate those entries. Please help both with the meeting minutes and also the high-level key takeaways that we have in the link at the bottom. On the next slide, we're going to see the first presentation by Jorgen, who was also part of the initial workshop, was a 3 or 4 person, as mentioned by Wes. He's going to discuss towards declarative, composable, reproducible, verifiable network and service configuration. Then Ian will have a perspective of 20 years later. We're going to have Wes, which is going to go 30 years later, or before, it depends, and lesson learned from NetSNMP. Karsten will discuss the managing IoT devices with Yang modules, and Rob will mention rethinking standardization of network management. So we'll keep the time on the right-hand side, trying to, as we said, spend as much time as possible for the discussion in the end. And I think that's it. We could be starting with you, Jorgen, unless Kent, you want to add something else to this intro.
Only that we're 3 minutes behind, but otherwise great. Thank you.
Okay, hello everybody. It's a pleasure to be here. So 20 years have passed and it feels like yesterday almost. But 20 years ago, the workshop was not the first time that the IAB gave directions to the IETF. We can even go longer into history. Just go to slide number 2. I don't want to lose time. So in 1988, there was an IAB recommendation for the development of the Internet Network Management Standards. The background back in those days was a conflict between competing protocol ideas. So some people wanted to adopt the ISO, OSI, CMAP protocol over TCP. Others wanted to build something simpler. And so at the end, the IAB gave a recommendation, and that was the birth of SNMP technology in the IETF. So that thing left a clear mark behind because we got SNMP, SMI, and hundreds of MIP modules standardized in the IETF in the aftermath of that workshop. Well, that wasn't really a workshop. It was kind of a teleconference, by the way. So kind of what we're doing now. And then we had the 2020 workshop. 2020? No, 22, that's wrong, which gave us a path towards standardization of netconf YANG and all the technology. So that was also kind of influential. So if this workshop wants to be a success in the sequence of this, it needs to lead to something significant. Yeah, so I'm putting the organizers a little bit under pressure here. So that's the history you're working from. Please go to the next slide. So let's focus on what happened 20 plus years ago. So to understand the context, we had SNMP technology in the IETF, which was a super good solution for monitoring tons of devices for little pieces of information. And that's what SNMP was really good for. But for anything that required more complex data to be exchanged or that wanted to make configuration transaction, SNMP was pretty much a pain to work with. There were some writable MIP modules. The IEEE was actually pretty strongly pushing on that. So if you had a layer 2 bridge, you could actually configure that using SNMP if you really wanted to do so. But in general, we didn't really have much writable success in MIP modules. And so the actual situation was that that operators used the command line interface, the proprietary command line interface, to actually configure systems. Within the IETF, the attempts to evolve the SNMP framework to go beyond what it was originally designed for kind of failed. And so that left the IETF in a situation that it was unclear what to do next. And I believe the workshop was organized to essentially drive this forward. So the workshop was organized with a specific idea or goal in mind. I'm not sure whether there's a specific idea or goal in mind for this workshop, but perhaps I will know by Thursday evening, I don't know. But the situation was that, like in the first workshop, probably, it wasn't clear where to go next. And the pressing problem on the table was configuration management, because there was essentially no widely accepted solution in that space. And the result of the workshop was that it was empowering the area directors to start new work in the IETF. And the area directors decided that an attempt should be made to define or to standardize a configuration protocol without doing any work on data modeling, without agreeing on data serialization formats other than it should be encoded in XML, because XML was sexy at that point in time, pretty much like ASN1 was sexy in 1988. And so we probably have a certain history to pick something that is sexy at the time when a decision is made, and then we regret it later on. So the idea was that if people manage to actually come up with a configuration protocol that people are also implementing and so forth, then in a second step, there might also be some data modeling work. What exactly that would be was unknown. And that, of course, left a little mark behind, because defining a configuration model protocol, if you don't know what the configuration data is you're dealing with, is a little bit of a hand-waving exercise. And so some of the probably not well-aligned issues between YANG and netconf is kind of a historic artifact of taking the sequenced approach. Next slide. So you all know what came out of this. So I just wrote down the dates when netconf came along. We revised it after a couple of years, so it became netconf 1.1. So that's kind of a timing of almost four and a half years between that. We had YANG coming out in 2010, and then we got YANG 1.1 about 5.5 years later. So we got different encodings. JSON came around when we also had YANG 1.1, and at that time already RESTconf was in the making. If you go to the web, of course, JSON was clearly the more popular encoding at that point in time already, and so that made a lot of sense. 2018, we got NMDA published, and CBOR, the latest encoding, probably is still very recent. I always like to look at specifications. So typically what you observe is that when a specification is out there and you get an update, it's getting longer, it's never getting shorter. And the question is always, how much longer does it get? Is that kind of meaningful, or are they adding a ton of additional complexity to it? And I tried, as someone who is in academia, I tried to get a handle on, what is the citation impact? Unfortunately, The IETF internal statistics tracker doesn't work at the moment, so I couldn't get those numbers. And so I ended up looking into Semantic Scholar that gave me some numbers, but I wouldn't trust them too much either. Using Google Scholar and other sources kind of turned out to be complicated because Yang is really a bad name to drive any statistics from. You get a lot of noise, but not necessarily what you really wanted. Next slide. I also looked into general statistics that I could get about technology. And again, the names are difficult. NetConf is doing okay, but Yang gets you so many wrong hits that it's really difficult to assess something. And I ended up looking at Wikipedia popularity because there you can actually measure the popularity to a page where you know what it is about. And I like this graph because it kind of expresses my feeling, and you can get easily other graphs. So the graph is not taken as ground truth, but it expresses my feeling that in terms of popularity in the general world, things seem to be way behind the hype cycle, and they're kind of going down. That might not be the reality and industry usage of this. That hopefully is better looking, but that's kind of what, if we do a Wikipedia popularity contest, you would get. Next slide, please. So reflections. So things that have happened after the workshop has been successful to a large extent. And so I was thinking of what were the factors that I think made this a success. I believe the first factor is that a core team of people were forming after or during, or probably more after the workshop, that were willing closely to work together. And these people shared a common goal of substantially advancing network management standards. So there was a clear understood problem to be solved. That was configuration management. And the people felt, yeah, there's a chance to do something that really leaves a change behind. And those people had a good level of agreement on priorities, not on the details. So there were still lots of debates on whether X is more important than Y. But overall, there was a good agreement on the core team, what the direction would be. Another thing that I find in looking backwards relatively important, there was a commitment to create a good and sound technology. So the idea was to go through the details and to work them out and not to take the path of declaring something to be implementation specific just because people couldn't agree. Back in the day, the big players from an industrial perspective have been, of course, Juniper and Cisco, and they had different software architectures. So there was a lot of discussion on how things could actually map to current implementations. Of course, the IETF has always been in the network management area, hardly focused on vendors and vendor implementation code, much less on the client usage of technology. And that has always been a part of the IETF and has shaped what the IETF has been doing. And another big benefit was, of course, it was a niche project. So some people cared about what was going on, but many people didn't care about what was going on. And that gives you a lot of freedom and flexibility. So you can have discussions without a lot of interest of many people, and you can do your own thing and develop your technology. The current situation I perceive as being totally different. So NetConf and Yang has been successful, and RESTConf, I mean the entire ecosystem. And we have many competing data models. We have other standardization organizations relying on IETF technology, so they write their own data models and as Yang modules. And so we also have to pay attention to usage data and other standardization bodies. The original core team has largely dissolved. Some people are still active. Some people we haven't seen for years. So that's a natural change. After 20 years, you should expect different people to take over. And we have new people active, but it might be that they have somehow different ties to the technology, and they sometimes appear also to have different priorities. And work also seems to be more fragmented. There are people that worry about telemetry, and that's what they're focusing on, solving that part of the problem, but they might not care less about other aspects. And in particular, substantial and architectural cross reviews are always going to be a problem to get. So there are lots of documents where back in the day, people would have had way more technical reviews and opinions about them. At least that's my feeling, my perception of it. Next slide. So I'm drawing a picture here of a certain configuration management fantasy, and that goes over 2 slides, and I put a bunch of terms in the title of my paper and also of this talk. And the fantasy is essentially built around 4 cornerstones. First, configuration should be declarative. So the idea is to define state, a configuration state a device should be in, but not single step a device into that state. And that was essentially the SNMP approach, where you would have to single step the device into the desired state from whatever state it is currently in. And if something goes wrong on the way, the management system would have to take care and repair. This got changed with the netconf approach because we have a configuration transaction, and of course that puts more burden on the device, but it helps making configuration declarative. The second thing that I think belongs to configuration management fantasy is composable configurations, where you can assemble a complex configuration out of composable units that more or less work plug and play and don't have any unwanted side interactions when you compose them together. Next slide.
And you're almost at the end of that time, so please speed up a little bit.
Yeah, so reproducible, something that a configuration really gets the device in exactly the same state and not in some close, exactly similar state, but actually in something that's reproducible. The last thing is verifiable, having verifiable properties that you can prove that a certain configuration has certain properties in terms of security, robustness, or compliance to certain regulations. Next slide. And so I would like to know what the workshop participants think about how close we are to declarative, composable, reproducible, and verifiable configurations. And I would like to know what the participants know or think about how close we are in managing device configurations and network configurations and service configurations. There's a QR code. If you're not afraid, you can just scan it and you will get to a place where you can answer those questions, and I can later then report what the workshop participant thinks. Thank you for your attention.
Thank you, Jürgen. So we've got time for, let's say, one clarifying question. Jürgen? Okay, so the next presentation is Ian.
Thanks very much. Could you bring up my slides, please? Okay, so what we've got for you is, yeah, RFC 3535, 20 years later from an operator's perspective. Specifically, I think we've got about 10 years worth of experience with netconf and Yang-based automation, but you know, there's obviously things from before there as well. So that's what I'd like to talk to you about. Can you go to the next slide, please? Yeah, let's start with the big point. Yang has been tremendously successful for us. And I think we can see this from how widely implemented it's been in a lot of the popular vendors' devices, and you know, most devices that you can buy these days in core at the edge in the network domain are supporting netconf Yang. And the big difference here from what we've seen previously is we're getting updates shipped alongside the software updates. And I think this is kind of one of the massive differences to what we've seen previously. When a new feature comes in the operating system, I can already manage it. And this means that we've got the firm foundations that we need to be able to actually build services on top of and be able to access the features that we're buying. Obviously, we have to do the implementation and the integration and keep these things updated, but at least the features are there and available. And this, I think, has been one of the most tremendous successes. And to echo kind of what Wes said, I was quite pleased when Wes said we're not looking to burn everything down and start all over again. You know, the success that we've got, we need to extreme trepidation with how we treat this so that we don't break the ecosystem. Next slide, please. One of the things that we've really come to love about using netconf, well, Yang specifically, is around how we can manage the devices, but we can build up from there and use it for defining resource-facing services, customer-facing services, extremely complicated customer-facing services that we can simply model and abstract in a way that they become manageable from the northbound. This is really one of the key strengths that we see here, and the fact that we're using a common language throughout is really what drives that. We don't have these impedance mismatches of translating between this API and that modeling type, and all of the overhead that brings with us. But one thing that we find is that this is not well understood outside of maybe the IETF and the Yang faithful, if you like. I see very frequently that netconf Yang are considered to be edge protocols. I can talk to my devices with it, but when it comes for describing and defining services, then we'll use other APIs, we'll use REST, we'll use imperative type configuration, and this kind of runs the risk of throwing the baby out with the bathwater. Having spent some time with the documents that have been published around this, this whole construct, the architecture, which I think we understand, it's not very easy to point to this and say this is the concept, that this is all underpins all of these ideas. And I think this is something that we would do well to promote more, to make it more understandable for outside of the IETF. Next slide, please. Sort of building on that last point, the L3 VPN service is something that we've really come to love, and I would say that we have not yet found a layer 3 connectivity service that we have not been able to use the L3 VPN service model to describe, configure, and likewise with the L2 VPN, although we don't tend to use that one as much, but really there's, it'll work for almost anything. It's very good for the technical configuration and description of services, and provides a really, really nice northbound interface on there. Elsewhere, though, in the BSS side of the business, we see that they have chosen some other APIs, particularly I see MEF, and most recently TM Forum has got a lot of traction there. These are designed to solve a bunch of BSS problems, which are maybe a little bit different to the ones that we're so interested in within the IETF, but there seems that there is a gap in what I see in the TM Forum models that is a really good fit with what the IETF's L3 VPN service and other service layer models can fill. But the way of doing this currently is not defined, and an interworking between ordering through BSS and the provisioning of using the L3 VPN services to find this, this is a really powerful combination, and it's something that I think some time could be spent on standardizing this, working with the TM Forum and finding a good interface between those domains that we can, would work for both sides. Next slide, please. Operational state and configuration. Historically, I think most operators have this kind of concept of you have design and planning groups that do configuration. You have operational groups that deal with running the services once those things have been configured and deployed. With the collection of state data telemetry to match. So you have the people doing the config that don't see the state data, and the two domains and the tooling and everything around those things have been traditionally very separated. Yang gives us a way of solving this. But this is something that is, well, A, not very well implemented, but B, needs to be propagated up the stack. So we can get telemetry data using Yang push from the devices themselves. We have these nice layers of domain and service models in which we can place all of these, that we can describe the configuration, but we don't have a place for operational data. And this means that we can't easily get a view of an end-to-end service, of components of the services. We can't easily do root cause analysis of this. And this seems like we are really, really missing a trick here for building what you call maybe a single place of a pane of glass type of management interface. Digging into, I think it's RFC 8309 has a short paragraph on this topic, which kind of says, operational data doesn't belong in service models, although you're free to augment it if you want. I think this is something that we could revisit at this stage and say, well, if I'm defining my services, I'm configuring my services this way, I also want to be able to see how they're performing. I want to be able to look down the stack and say, if this link failed, what's the impact? Okay, next slide. I've got some echo for some reason.
Rob, can you turn off your video and mic, please?
Can I have the next slide, please? This one's a biggie. So yeah, we talked a lot about what we see the server implementations in devices, and you know, that's going very well. The client side is definitely the poor relation. There's a few open source tools around. There's some Python libraries and things that implement that are, you know, quite widely used, but it's nothing. There's nothing there, or there's really only one option that you might call an NMS platform, and this I see as being a barrier to adoption. Within our organization, we have a bunch of different operating companies, and I've lost count of the number of discussions that I've had where people have said, we can't go down this line because of the risk of vendor lock-in. And so what we see is very well, solutions being created using SNMP, using scripting, using all the things that we kind of have been trying to get away from. And you know, any technology lives or dies by the implementations, and you know, whether there are good tools to be able to use that technology. And this one is a clear gap. The IETF, in my experience, has not traditionally worked on open source tooling particularly, but this seems like it might be a point where some leadership here around finding some initiatives and maybe finding a way that those could be supported could significantly improve adoption of the protocols. And last slide, please. Yeah, this one's a bit of a head scratcher. So the amount of hours that must have gone into developing protocol device level standardized models in the IETF is enormous. However, the number of implementations that you can find of any of these device models is practically non-existent. Some of the core ones you can find in some open source implementations. I'm aware of one commercial vendor that implements things like IETF interfaces, IETF IP, etc. But to all intents and purposes, these standardized protocol and device models are pretty much non-existent in implementations. Part of the ideal that we would like to see there is that we would have a way of using these as our abstraction layers down to the vendor's proprietary, or and so possibly some kind of off-box implementation. I think Kent mentioned this in previously, but something like that we could collaborate on, I think would again be a massive benefit to really kind of realize this idea of abstraction, vendor agnosticism, you know, and a lot of things that we would like to see as operators. And I think that brings us to the end. So any questions?
No question for Ian.
Okay.
Thank you very much. So while you were talking, I took also some notes in the key takeaways. Please review yourself and Jorgen if you did a good job over there. Thank you. So Wes, do you want to discuss the lesson learned from 30 years of NetSNMP, please?
I sure do. So I will preface this by saying, one, I don't remember which version of the slides you actually got, and that's okay. And two, this will be a little bit negative in a couple of ways, and that's intentional to try and provoke some thought. So go ahead and skip forward 2 slides. One more. Yep. So a little bit of background on how all of this got one less than that. There you go. I was originally hired by UC Davis for the electrical engineering department, and we had a large number of different types of machines, like campuses often do, with different operating systems. All of those are very old, as you'll recognize. And we had problems on all of them. Sometimes, you know, daemons on Ultrix would kind of crash and disks would fill up, but they all had different sort of partition sizes, and we needed sort of different ways of knowing, you know, is this a problem or not? So I got hired to sort of fix the problem. And the goals were, you know, can I fix them, you know, sort of automatically, right? Because a lot of the times, you know, you just needed to restart Mount D or something like that. But we didn't know that it was broken until a student came and complained. But we didn't want to do it automatically to the point of, you know, restart it every second if it's not running, because that runs into a different set of problems. So we did want a human in the loop. Next. So basically, my task was, I don't know how many people remember HP OpenView, but that was sort of the network management platform back then. It later became Network Node Manager after that. But this is what our diagram looks like, and this is pulled off of somebody else on the web. I actually went looking for the, you know, a snapshot of what we had at the time, but couldn't find it. And I was told that, hey, look at the SNMP protocol because it's what OpenView speaks. And we really wanted to warn, you know, the staff before the students complained that something was broken. So let's make the things turn red, yellow, and green, like people like to know when things were problematic. And at the time, CMU SNMP was the open source toolkit worked on by Steve Wallbuster, who I actually just talked to a couple of months ago. He's still doing well. And I ported it to all of our systems. At the time, it only ran on SunOS. It was really just a reference protocol. It wasn't designed to be, you know, an end agent and an end management service. It was just a reference for this is how SNMP works. Next slide. So this sort of became how my entire career life cycle has worked, right? I was an operator on our campus network and services. I had problems, so I ended up having to write software that later became NetSNMP. And that got me involved in the IETF because I really wanted to go to V3 for security, and that was sort of spinning up at the time. It was past the V2U, V2 Star Wars. And that eventually got me into doing more research to look at long-term problems in routing and long-term problems in the DNS. And that eventually got me back into operations. And now I'm managing a large-scale DNS infrastructure. I run a root server where we do a lot of network management. So I keep going in these circles. And why? Because I'm always wanting to improve things, right? I'm always trying to figure out, okay, what's the next step in making my operations better? And that always ends up to eventually tinkering with protocols and software and then everything else. So next. So this is sort of what I just stated on the top, but one of the things that I came out of this is when you are dealing with network operations, it's often very complex. And so every time I had to answer a question, be it to my own staff or to NetSNMP users on the mailing lists, if they were asking a question and I was seeing that question 5 times, then it's either the fault that there's not enough documentation about it or that the feature itself is too complex. So I ended up actually, you know, taking that as a mandate where every time I saw 5 times, you know, somebody asking one question, I would try and update the software so that question would go away. That worked really, really, really well because eventually the questions all got too hard. So all the simple questions went away because I made it, you know, easy enough to use. Next. So my easy to use started with a very basic configuration parser that really just said, what are the problems you want to look at on this machine, right? Is slash, you know, does it have at least 10% free? Is Mount D actually running? And I created some SNMP tables that weren't really complex configuration things. They were simply, is it running or not? You'll notice that the second to the last line is an error flag, 1 or 0. Is it an error or is it okay? Right? It wasn't complex, it wasn't intensive, and there was a string that went along with it. That is actually why NetSNMP eventually became so popular, because of the simplicity of what was going on. It was very easy to put into HP OpenView to make it red. Done, right? Next. So essentially, I originally published it as a patch, and it got hundreds of downloads in a week. Now, so mind you, this is back in like late 1990s, I think. To get hundreds of downloads for an obscure protocol, you know, that nobody has ever really heard of is really kind of weird. Eventually, it was published as UCD SNMP, and then I got so many developers and left UC Davis that I eventually rebranded it again to NetSNMP, and it's now has a set of core developers and a lot of patches and issues that are still coming on a regular basis. But why, right? Why was it popular? Why is it still popular, even though it has faded in its popularity? If SNMP is a horrible protocol, why was it so successful? Next. One more. So the reason is it had nothing to do with the protocol, right? Throw the protocol out the window. The whole goal was to make things simpler for operators and to make hard things simpler, right? My whole goal of answering questions too many times, to make things simpler, and to provide easy to use documentation, easy to use configuration. And so we supported a number of things that made local customization and extensibility possible. We had simple config. It would hook into writing your own shell scripts if you wanted, that would output through the protocol. We had an embedded Perl within the agent. We had an extensible agent that allowed you to, extend things in various different ways. People could easily take our agent and run their own stuff for their own solutions, for their own networks. Next. So we did fail in a particular rate. Way back in the last workshop, we were talking about SNMP sets and the fact that configuration for SNMP was a pain. And I actually went about trying to fix that too, right? People were saying at the time that SNMP sets were 5 times harder to write than monitoring. I think they're absolutely right. It took a lot more code to support a set than it did to support a read. We probably helped. We got it down to like 3 times as much because we handled a lot of the state machines. But the reality is, ACID is hard on on an entire network, right? Ensuring that these 3 completely different components of one device, let alone 100 devices, will all either succeed or fail, which is, one of the reasons NetConf came around, is to be able to update everything at once with, either succeed or fail. The problem is sometimes there is no undo. Right, my co-developer for NetSNMP, Dave Shield, who was the first person to ever submit a patch to me, listed it really well. There's at some point you have to say launch the rocket, right? You can't use ACID to get the rocket back on the launch pad at that point. You're done. And for operations, that's exactly what can happen, right? It's not just writing config. You're making a major change. It could be bring the interface down that you're communicating over for management, right? There is a point of no return. And that actually, I think, is one of the things that we're missing to a large extent in all of our efforts to deal with these kind of problems. And none of these are new conclusions, right? These are all problems that we discussed 20 years ago. Next. Next. So what did we learn from this? It's not the protocol. It's the easy use and the adaptability. And the real issue is anybody that runs operations, anybody that runs a network, I guarantee your network's different than mine. Like every single one is a unique flower or a unique snowflake. And that, I think, is the thing that we need to figure out how to concentrate on. It's great if we can standardize, here is a module that works so that everybody can represent their entity using the entity MIB, or here is a Yang module that represents, all of the interfaces. But the reality is how those all tie together is very different. Next. So what operator tools do people really like? I use all of these, right? Prometheus allows you to run your own shell scripts, just like we did. Ansible does things in a dependable order and only interrupts you when things go wrong, right? Puppet is kind of different. You declare what you want and hopefully everything goes right, and then it tells you when it doesn't. Web APIs, if you can use curl on something, operators love that, right? If you can cut and paste a command line for using curl, you win. JSON is for the same thing. YAML is for the same thing, right? They're easily understandable. You can quickly read it in any language. Go look for JSON modules for any language. I guarantee there's at least 5, right? Docker, on the other hand, is actually quite complex, but it's very reproducible, right? It actually saves you. It doesn't matter what your operating system is, because underneath the hood, it's going to use the same thing underneath the hood. Operators hate things that are complex because they don't have time, especially security operators. Next. So what does this all mean? Fundamentally, there are 2 different audiences, and I have concentrated only on the first one, right? Operators need simple things that adapt to their unique flowers. The tool vendors, which I'm not getting into today, can actually handle the much more complex protocols with huge data models. And SNMP was hated, 20 years ago because nobody understood relational data tables, and that's what it was built out of. It turns out that hierarchical data tables are definitely better. You can parse them with JSON, but if they get too crazy, operators are not going to like them either, right? They need simple things. So the problem is as we come out of this workshop, we really need to optimize for both in order for anything that we do in this workshop to succeed. Next. So 20 years ago, I presented a discussion, I think at an ops area working group, that we had a new dog, which was netconf, and we had a new car, which was netconf, and an old dog was SNMP, which you can't teach SNMP old tricks. I warned people that we don't want two things, right? Is if we have to have two different protocols, one for monitoring and one for configuration management, then we're going to have twice as much code to support, twice as much documentation, twice as much. I think we've failed this. I think this is where we are today. Maybe I was wrong. Maybe we actually do need two. I don't know. It feels like we have 12, right? I just listed a whole slide of tools that were not SNMP and not netconf. Next. So, going back to today's questions, and these are very much in my opinion, right? RFC 3535 requirements, I think we failed number one of the operator requirement, ease of use, right? I'm not sure that netconf with Yang is easy of use. Certainly SNMP is not easy to use. I think we've shown that shell scripting and being able to, adapt is what people need on the operations side. The state of the art is that operators do what they need to survive. They have very little time and they need to be able to how to spin things up quickly. If there's a great big management tool that does it for them, great, they'll use it. If they can't make it adapt to their environment, they won't. So the operational barriers are, as I said, ease of use is sort of the barrier. And without ease of use, it doesn't matter what the technology is. It doesn't matter what the protocol is. It's not going to be used. Unfortunately, I did look at the graph. Jürgen nicely created a graph of netconf in Google trends. I challenge you to go look at SNMP too. It declines over time, as it should, right? It's a dying protocol. We want it to go away. It's still like 5 times higher than netconf. Why? Right? Netconf is declining too. Then go add the graph of Ansible. It goes up, right? What is that telling us? What can we learn from that? And I think with that, any questions? Sorry to be so negative.
I'm just thinking about your question. So any clarifying questions in the meantime to Wes?
I have one. So you talk about simplicity, right? Or that we should avoid complex solutions. And I'm a little curious if you think that this is, intrinsically like the protocols themselves, right? Because I think in the comparison, you talk about curl, that's a tool, right? That is not a simple thing. It's, I don't know how many lines of code, right? But it wraps up something that is more complex and presents a very simple CLI interface, right? That we can use. I mean, do you think is it okay with tooling, or do you actually think that the protocols that we defined are too complex?
Excellent question. So I think that the protocol that curl uses is HTTP, right? So there is that protocol.
Mostly.
Yeah, well, right. So I would argue that the availability of tooling is paramount, because if you can use something, so in the network management arena in the IETF and in the operations world, there's a lot of tools and a lot of protocols that are very specific to just our need. And that, to some extent, is why we fail, right? If there's JSON parsers for every language, and I recognize we're moving away from XML. It was the hotness at the time, right? Jürgen was right. There are better things now, and we should be pushing it. And netconf is moving to, maybe that'll help. I don't know. But if we are determined to have very specific data models that are very specific to just our use case, that can't be read by, a gazillion tools out there, then take-up's going to be hard, not impossible, but hard.
Yeah, thanks.
All right.
Thank you, Wes. So, Karsten, You're going to discuss merging IoT devices with young models.
And just quickly, every time I share slides, it seems to start on some random slide, not the first slide. So you always see me needing to scroll back to the first slide.
That's because you have
Right.
history.
I have some 30 slides, so if you can give me control, can I share this thing?
I cannot give you control, but do you know have a slide number?
No, I think we can stop sharing and Carsten can share. That's fine.
Oh, yes. Did you want to share, Carsten?
Yeah.
Yeah, I'm trying to.
Carsten has tested, so his sharing is okay. So we can just stop sharing.
Yep. Sorry about that. Go ahead.
So you should see my slides now.
Yes.
Yes.
You see my slides now? Perfectly. Okay, so I want to talk a couple of minutes about CoreConf, which is one of those environments that is different from everybody else. So it's actually worth looking at, and it's different for a reason. So it's I'm going to start by talking about the reason. But quickly about myself, because not all network management people are going to know me. So I'm working on the Internet of Things for about 20 years now, currently in the IETF core working group and a few other working groups, and in the Thing-to-Thing research group. Now, what is the issue about the Internet of Things? So the first thing that we heard was that people were thinking about scaling things up. But that's trivial. We know how to scale things up. We have been doing this for decades. The new thing in the Internet of Things is that you have so many of these things that you have to scale them down. You cannot treat them like other nodes where you install software when you have a problem. The things actually have to work in the way they are. And they might have some rather limited environments because they have to work from limited power, like a AA battery cell or a knob cell. So something like 10 kilobytes of RAM and 100 kilobytes of code. That's an environment that we might want to work in.
Spook, dude. And you know what a spook is? Black project. So that's the only thing you need to fucking know.
John Carson, can you turn off your microphone, please?
Okay, that seems to be the case. So the last observation I want to make here is that Moore's law, which is always helping us everywhere else, applies a lot less in this physical world, because if we get improvements from Moore's law, then we probably are going to put them into saving power or saving cost and not actually expanding the amount of computation we can do. So in the IoT space, we have a very different complexity scale where we think in terms of kilobytes and try to minimize listening times and so on. So none of this is new. IETF actually has been working in this space, as I said, for about 20 years, starting from making IP run over constrained networks upwards. We now have a lot of security activity, which I think is really important. So when we started to think about IoT management in the early 2010s, we kind of looked at the situation and said, oh, there's a simple protocol. There's something that could be run on anything. It's UDP based, so it doesn't need to keep state. Well, it has a weird modeling language that is going to slow us down. But the ASM object identifier technology was an interesting way to give control to people and get flexible delegation. And there even were some people who thought SNMP could be used as the application protocol because there's really no limit to what you can do. So if you can read your bit rate, you can read your temperature and supply to a thermostat as well. So this was a pretty interesting approach. What we found pretty quickly is that we had to make these MIBs, and we actually managed to get one MIB out there. So Jürgen, who had a talk earlier, was very instrumental in getting a 6LoWPAN MIB out there, but this didn't scale. So we had a serious problem with the human complexity of SMI v2. And also, since there were application protocols out there, there was a certain reluctance to have separate protocols. See, we are really trying to minimize the code footprint and the complexity and so on. So what is our application protocol? Of course, there are many application protocols, but one that was very important at the time when we started this was coming up in the core working group, Constrained RESTful Environments. And basically, the idea was to take the web protocols that we all love and see how much we can move of that into the constrained space. And well, web means HTML, URIs, and HTTP. Well, HTML had to be changed because this was not about human to machine communication, but machine to machine communication. URIs worked right out of the box. And HTTP, yeah, that kind of works, but it's expensive. So what we set out to do is do something that is as simple as possible, but not simpler, which is, of course, a good thing. So we came up with something called the Constrained Application Protocol. And we just took HTTP's API that everybody knows and understands and can use, and put a much simpler protocol below that. Of course, we did lose a lot of the baggage, but it's good enough to do useful things with an IoT device. So it's now a very simple protocol, datagram only initially. At some point we put in TCP as well. It has a 4-byte header, a very compact options encoding, and so on. And it has an interesting feature called observe, which notifies you of changes in the value of a resource. So when you look at examples, these really look like HTTP. So any HTTP developer can immediately do useful things. If you look at the messages, you can see the individual bits. It's not like in HTTP where you need like 500 bytes to do something. So that was standardized in 2014. And I probably should add that we had a very credible security story with CoAP as well, right out from 2014, which kind of makes us reluctant to do another application protocol because that comes with another security story, and security is the most difficult thing to get right in this space. Of course, there are different layers that might do security. Yeah, I'm not going to go into the details, but we have a security story. So after SNMP, the next step would be to go to the single request response protocol that we use for everything, which is called CoAP. But then we still would have ASM1 macros, and we didn't really want to have those. So we were lucky. Yang started to exist, and well, it's a little bit more heavyweight than SNMP, but it's purpose-built for network management. It has models that I can actually work productively on. It has RPC and actions. It has notifications, so all the things that you need in this space. Yeah, it's based on XML. It's based on text-based data being carried around in that XML. JSON is better a little bit, but not much. It's still all text-based. And well, it has text-based identifiers, which becomes a problem when you have lots of identifiers in the structures that you exchange. So we might even want to use Yang models for applications or application models for network management. That's a thought, which I just want to plant here. So how does this work out for us in the IoT space? So we tell everybody you can use Yang. And the answer is we cannot really run XML on these things or send all our data in JSON. There's lots of computational complexity, RAM usage, energy use, which is really important. So it's really unlikely that a random thermostat you buy on AliExpress is going to come with a Yang model that you can use. That is something that we really want to do. And on a higher level, the netconf and restconf protocols have a certain architecture that is expensive, which you see when you look at the data store architecture. So we thought, what can we do without losing the benefit of using Yang? And well, the two biggest problems we had was the text-based data and the way identifiers are done. And this is the two RFCs that got mentioned by Jürgen in the chat. Yang CBOR says how to do essentially Yang JSON, but based on the binary representations, the efficient binary representations in CBOR. And Yang CBOR also can use integer identifiers. So you don't have to send all these long identifiers of the various data tree nodes around. And these integer identifiers have to be managed in a way, and that's where the other document, the other RFC comes in, which is Yang SID. So SIDs are integer identifiers for data tree or schema nodes, so you can get a very efficient representation because they actually compress well due to locality, so you can use data compression. So these are two foundational parts that everybody who wants to use Yang can use. And then we finally set out to map the Yang protocols to CoAP, which is called CoreConf or COMAI sometimes. So we used what we had in the CoAP protocol. And also we simplified the data store model, data store architecture for now. And yeah, people are using this stuff, not in large production networks, but in research projects. Interestingly, often for doing security configuration, which is very interesting, or for doing something like compression configuration, which you need to make use of millibit networks. So that's where we are. COMAI is nearly done. We are still currently looking at a few possibilities to further simplify it, which I think is a healthy direction to go, but it shouldn't take us very long to complete that. And you can implement it today. So I want to mention that we have some activity here on further improvements. Getting rid of the text-based common Yang data types like IP addresses and time. That's of course important if you want to stay with small packets. So we do have a proposal how to do this, and we still need to fully understand the ramifications and standardize this. And there's also Yang metadata, which Yang CBOR currently doesn't do. The more interesting question is how can we change the RESTconf-based COMAI to limit the subtrees that we might get from a device. And there are good role models here, the depth parameter, the pagination extension, but we have to see which of this stuff actually works in the IoT space. Okay, I'm sitting here and reporting this, but I have done almost none of the innovation here. So I saw that Alexander is actually here in this meeting, but there was a cast of several people who made this happen, and I wanted to mention them. Thank you.
Thank you, Karsten. Any questions? Ruth, do you want to ask your question? Shall I ask it on your behalf? Oh, I say Alexander. Please go, Alexander.
Yes, hello, hello everyone. Thank you very much, Karsten, for this wonderful presentation. And of course, just a very short question. You know that, like, we know that Yang Seaboard has like a much more compact representation of the same data compared to JSON or XML. So have you seen like requests or adoption from or in your opinion, in other uses that could be used in netconf, for example, this kind of encoding, Yang to Seaboard. So not only with within CoreConf, but like more generally. So.
Well, we have heard interest from vendors, but I think it really would be interesting to see what the vendors come up with here. So then we can look at whether it's something that we might want to standardize. So we do have standards for Yang Seaboard and for Yang SID. So we are essentially done in that area. But then looking at netconf and even RESTconf, which can do XML and JSON and easily could do Seaboard, that would be an interesting piece of work that maybe should be done in the network management space and not in the constraint space.
Okay. Okay.
Karsten, can you stop sharing slides so I can?
Yeah, if you start sharing, you throw me out, but I can stop as well.
So, Karsten, there is a question from Ruth on the chat. Is it right for me to get the feeling that model-driven network management techniques have been more successful in IoT networks compared to others? Any views on that one?
Probably. The real problem that we are running into is that we have the pet versus kettle problem, not just on the instance level. So we have 10,000 things doing one thing. It turns out that we have 10,000 classes of things that we have to somehow manage and run applications on. So doing things in a model-driven way is essentially the only way to manage this complexity of everything being almost like everything else, but with little differences.
Okay. Thank you. So, Rob, rethinking visualization of network management.
Thanks, Benoit. Kent, next slide, if possible, please. So just a little disclaimer before I start. Everything I'm going to present here is my personal opinion. I've been involved in running networks as an operator for the last 20-something years. I guess I should have been one of the main customers of the outcomes of the last workshop, but I don't think I was quite old enough to come to the original one. But my background is running, small-scale networks, regional NSPs, multinational telcos, application service providers, and now I'm at Google. And I've spent the last 10 years really focused on network management, and I've been the tech lead for the OpenConfig project for the majority of that time. And as those of you that have seen what OpenConfig's done, we've been very involved in using some of the technologies that came out of the previous workshop, but also taken some other approaches. And so what I wanted to share was not necessarily say, like, this is exactly what the IETF needs to do, but really think about, well, what were the things that standardization of network management needs to give for operators to be able to make the outcomes usable? And really, the fundamental question I want us to think about is, how do we think about developing software and not just developing standards? Because at the end of the day, what operators are trying to do is achieve some business outcome. And in this world, it's, when we're managing some network, then it's software on devices, but it's a lot of client software off devices as well. And we need to figure out, how do we get that software to exist and be written and be productive for those operators, not just how do we get an RFC carved. And my belief and the experimental evidence I have from 10 years of trying to do this is that the process in the IETF doesn't actually work for that requirement of shipping software. So the next slide, please. So the first thing I think that we need to think about in how we look at this problem space is we have to leave room for iteration. We've developed things like GNMI, which is a protocol for both config management and streaming telemetry that now are widely implemented across a number of different vendor implementations. And when we were developing that, the problem was we didn't sit down and write a specification and solely develop that in isolation. We needed to both implement the server side and the client side to really understand what how that protocol should work, how it was usable. And I would say we needed even more than just one implementation of that approach. We needed multiple implementations so we could learn the ways that it mapped. And doing that sort of multi-vendor, multi-client development experience gave us an understanding to be able to address all the nuances. So we found, that the specification we thought we wanted had bugs. The implementation approaches that we wanted to take guided what we needed to implement. And so we've tried to keep this as a really living approach, a really living standard and really living specification. And so that gives us a really easy way to be able to address problems as they come up quickly and in response to implementations, and not have to over optimize for the large scale case early on. So for example, things like being able to add more compact binary encodings into the protocol, very easy to add later on in a quick way, but only when you have a business problem that comes up with. And so we found that the standards process hasn't really, in the IETF, with the kind of velocity of it and the way that it is driven, doesn't really give us that ability to change in the same way. And so really, I think there's a question is the IETF the right place to standardize some of this this infrastructure if it's going to be driven the way it has been? Like, is the IETF going to be a keeper of specifications that are sort of carved into stone? Or is it going to be a more iterative organization where we might be able to have standards that mutate more easily, or have parts of the standards only apply to things that need to be clearly interoperable? And we tried the latter approach previously, as with some of the technologies we've used in OpenConfig, both GNMI and gRPC. We tried to bring them to the IETF as things that they needed to be interoperable. They were multi-implementer, but they didn't really necessarily fit within the standards process. So I think having a standards process that allows this iteration, but also thinking about the role of the IETF, is an important thing to think about. Next slide, please, Kim. The IETF process is too slow. One of the problems I would say I've had across the 3 different organizations that I've done network management for is you have some business need that arrives, some problem that the business has, and you need to solve it within a reasonable time period. And that reasonable time period is probably measured in months, if maybe a year, but it's not a long standards process. It's not aligned with the way that our standards process works today. So what does that drive? It drives us to go and have implementations of standards that aren't being iterated on within this environment, or being discussed within the IETF. And really, if I look at this, the operators that I've worked for, the engagement with the standards process has rarely been looked at as the outcome, right? Like, publishing an RFC has not ever been an outcome for one of those operators. It's always been achieve some business outcome. And so I think we have to think about, how do we take the approach of what we're going to, if we look at a different approach today and say, how do we really look at how the things that we come up with are in implementations quickly, so that they're aligned with what operators actually are able to align with the timescale on which operators need to actually use them. In OpenConfig, we tried to, again, like, to bring a data point to it, we tried to do things in the IETF, but really found that a lot of the iteration, a lot of the discussion was just much too slow for us to be able to actually adopt that and drive it into implementations. Next slide, please. And I know we've talked a little bit today, and we've mentioned network vendors. And one of the key things that I think we should think about when we're talking about about network management is it's kind of different to other areas of the IETF. like especially in terms of those that are more involved in routing or touching network devices, because yes, there's a few router vendors that that might be involved here, but there's many different client systems, and the client systems need to integrate into wider ecosystems. So, like Ian mentioned about integration with the BSS layer, or even with other OSS systems. There's a lot of integration of how those client systems fit together, and I would say the variety in number of operators is much larger than the variety in number of device vendors. And that's really marked when you look at the different sizes of network operators that we have. If you look at sort of, you know, the larger folks that might be represented here today, well, they probably have a bunch of software engineers. But if you're in a small network engineering shop, then you might not have any software developers. So there's really a need to think about how do we enable that client ecosystem in a way that lets different operators adopt it. And my belief is that that's enabled by open source. And the reason I think it needs to be enabled by open source is there's many operators that we have that don't have their own software development capabilities. And so we need to think about, as we develop these approaches, how is it not just a standard that's coming out, but it's also going to work with those open source developers, those open source communities that will get the implementations out. And a real critical thing here is that, you know, network management really needs that tooling to exist to be able to make it usable. I was looking at Yang, I think it was mentioned in the chat earlier, you know, there's still relatively little tooling around Yang, even though we're talking, you know, 20 years since the conception. And that's a really poor outcome for being able to have other folks adopt it. Next slide, please. The other thing I would note is that clearly operators are not automating just for automation's sake. They're doing it for those kind of business outcomes. And if we look at the RFC that we're talking about, the 3535, a lot of the operator outcomes are not individual bag of bits problems. They're things like manage a change across the whole network, which is a systems problem. It's not just hey, I need this particular tool, I need this particular API between two elements of my system. There's a whole architecture that needs to fit together that says, how do I determine what that change should be? How do I develop the input for the systems that need input? How do I validate that input? How do I safely apply it across the network? How do I do rollback or roll forward to a safe state or leave the network in a safe state? That overall thinking means that you need an architecture, and the bits that you build, the tooling that you build, the APIs that you build need to fit within that architecture. So I think here again, as we look forward, I would say that one of the major focuses that we should look at is how do we think about, is there an architecture that we can start to define that gives us an approach that ties the things that we're building together? And maybe that's reference architectures. Maybe it's collaborations with other SDOs to say this is what a system could look like. But being able to figure out how you don't just have a bag of tools that you go and build, but a system that achieves some business outcome, that's what is going to get operators being able to adopt the outcome of the work here. And then last slide, please, Ken. The other thing I think is we need more reuse. In the IETF, I think there's often a feeling that we're kind of starting things from scratch, very little looking at what's out there, and necessarily adopting, you know, technologies from outside of the IETF. And one of the problems with that is it's really bad for velocity. You know, clearly we end up with having to start again and, you know, redefine a modeling language, etc. But also for implementation perspective, again, that tooling around Yang. Well, if we kind of are relying on a very small community of folks that are really interested in network management to write our tooling, whereas you look at Thrift or Protobuf or other approaches to data modeling, you could build on top of those approaches to be able to really focus on the network management system and the network management problems. And so really, I think we should think about how do we steal as much from elsewhere as possible so that the folks that are in audiences like this, where we're really, you know, focused on the network management problem space, can really think about the networking specific parts of the problem space, not just the technology ones. And really, I think the way that we do that is we start to look at how do we look at the distributed systems that are out there and reuse what's there. And there's some really interesting cases of open source reuse of things like Kubernetes for network management, which gives you a basis to be able to build on top of without reinventing the wheel. So that's everything I have to say. I think the paper that I wrote has a little bit more detail in it. I tried to just flick through what I see as things that are really critical for us to think about.
Very good. Thank you, Rob. Any clarifying questions for Rob? I see Michael.
You said that, Rob, that you emphasized the need for open source. And you also said that there are many entities that didn't have a development aspect. And did I get that right?
Yeah, I think if you look at the sort of smaller operators, you'll see folks who are kind of maybe writing scripts that are gluing together different open source libraries. There's like a lot of screen scraping libraries, or we've found the same for like publishing GNMI clients. And so they've kind of got some limited development experience, but they can't really build the ecosystem. Whereas like a Google, I say, hey, I want to build a telemetry system, and they go build all of it, right? Because I just wheel in some software engineers to do that. And so I think that open source is a critical part of enabling those other organizations, those smaller orgs, to be able to reuse the things that we define.
So I'm latching onto that because I mean, I think that one of the spaces that a lot of people don't understand about open source, right? I mean, I had one economist say, well, why can't you do, accept venture capital? And it's like, well, because there's no ROI at the end of the day, right? And the concept that if you're doing open source, you have to be scratching your own itch or it's not sustainable. And I'm wondering, like you just said, Google versus the guy that has some scripting capability, and it seems like we're missing a waistband here, and some pieces in between there. I don't know how the guy with scripting interacts with the Google development team, or maybe it just works. I don't know.
No, I think that they're different, different types of organization. What I've done, we've said everything that we're building, we're going to build in open source because it is important, from the like open config projects perspective, it's important to have make the approach be multi-consumer, right? We don't want it to be a proprietary single operator to vendor interface. So we've essentially written a bunch of code, and we start with open source. Okay. But how do then other operators pick it up? Well, then there is at least some starting place for them to be able to build on. So if you look at GNMI, for example, Netflix picked up a bunch of code that we had open sourced and built a system that other folks were using for monitoring that was a more holistic solution. And so that's where there's some overlap between the two. But I think as a community, we should think about, well, how are we going to seed things? Because the number of operators that can write and write those open source solutions is much, much fewer than the number of consumers.
So we are out of time for this presentation, but there are 3 more questions in the queue. Let's do the first one, and if the other two, Suresh and Rashad, if you post your questions to the queue, that'd be great. Alexander, do you have a quick question?
Yes, so very, very good question. I mean, it's for me, like, thank you very much for the presentation. It's like, okay, you have at one side, you have like the RFCs, which are maybe slower process, and then you have like an open source where you can basically like change the code every other day, and things will be running in your branch, right? Is there like a suite? Are there places where this open source thing, where like you change the interfaces every other day and they break other things? Is there places where it's not appropriate?
For sure. I mean, I think it's actually not appropriate in any API that has one company implement one side of it and another company implement the client of it. So in those scenarios, like, you can't change it every other day, right? You change it every other day, and then you end up with a system that doesn't ever work. So there is some need for standardization here, right? Like, if I didn't believe that there was some need for standardization and to be able to have specifications that are clear and change control, then I wouldn't be here. But I think what I see is that I mean, I often say that the way that we look at standards in the IETF is you spend a few years picking a bit of stone and then you get your chisel out and you start carving, right? I would like us to think about how do we get a bit closer to being able to iterate much quicker, and especially with input from folks that are actually deploying these things and finding the bugs in it. Because I think like we're very, very slow at that, and it's not great.
All right. Okay, great. Thank you. And I think Benoit wants to share.
Right, so I want to share my screen.
Yes, so now we're moving into the open discussion part of the session.
And I've got 3 screens, and WebEx is stuck, or I'm stupid. Most likely the latter. Okay. All right, so what we want to do here is basically, if you see my screen, I have on the left-hand side the questions that we want to ask.
Benoit,
right?
I see your screen, but it doesn't seem right. Is the WebEx, I see WebEx on top of a white window behind it.
Okay, so is this better now?
No.
Okay. And what about now?
Nothing just yet.
Okay. So hopefully you see the right one now.
Yes, we have it. Thank you.
So what we have on the left-hand side is the question that we're trying to answer. There is one about the RFC 3585 requirements variation, but maybe we need to look into the specific of this success spreadsheet. Now, the questions are mainly, what is the state of the art? What are the lessons learned, the current deployment, what works, what doesn't, and the operational barrier. What I have on the right-hand side, this is the link that I shared at the beginning, and maybe Kent, if you want to share it again on the chat. And I've been trying to take some notes from the presentation, but also some notes from some notes from the presentation and during the discussion, right? So feel free to review this and let us know what is missing. So please use the +Q in the WebEx chat window. Ken is going to manage this. So something else I want to mention is that the program committee has been selecting some papers for 3 different days. Now, most papers, I mean, don't focus on a single day, you know, the past, the present risk recommendation, the present risk requirements or future risk recommendation. There's a little bit of everything in there. So maybe we want to hear from the people that have other papers if there are things that are missing into what was discussed for state-of-the-art deployment, lesson learned, operational barrier. And I'll be trying, with the help of Kent and the other, to document this on the rights. And that means that I will have to go into the editing mode. So that's why it might be good if you look at your own view of the notes. So Ken, do we have anybody in the queue?
Nobody's in the queue just yet.
Wim, go ahead.
Wim Hendrickson.
So the one thing I wanted to call out that we did not highlight, I put it in the chat, is what I've seen and that's mainly with respect to Yang, is that there are still vendors that don't have full coverage with respect to network management. And I mean, I've recently, because I'm developing some open source tools that hopefully will help us with some of this stuff. But so So one of the challenges that you have, which wasn't really highlighted in the presentation, I think, with respect to Yang, is that not all vendors have full coverage. And as a result, then as an operator, what do, right? So you do half this, half that. So people tend to then go to the least common denominator, which is screen scraping, or if there is another API, use another API system that they have available. So that's, I just wanted to share that that wasn't addressed, so I just wanted to share that part that I've seen personally.
Thanks, Wim. Suresh, you're next.
Hey, thank you.
Can I just ask one clarifying question on this, Wim, because I'm taking some notes. What does it mean full coverage? Is this as soon as we've got an RFC published? Is this, as Rob was mentioning, as soon as you got a draft? As soon as we've got like an open source implementation? Can you expand a bit on this, please?
It's the vendor implementation, so I don't think it is necessarily related to the IETF, because it's basically the vendor implementation itself that doesn't have full coverage of the modeling from their device with respect to the Yang protocol or NetConf protocol or GNMI protocol. And as a result, that hinders people adopting for that implementation, given that the customer or the consumer of that system doesn't have then all the capabilities that they need to have. So it's not necessarily an IETF issue, but it's an issue with respect to the protocol if you do not have that full coverage. You see?
Thank you.
And Wim, just do you mean full coverage, like as if the device has a CLI and a native Yang model, and there's divergence between them?
Yes, correct.
Perfect. Thank you. Suresh?
Yeah, thanks. So like going back to Rob's point, right? So Rob was talking about like, the implementation following closely, and we're like, we need the feature velocity. And I totally appreciate that's something that we need. But the part that worries me is, right, like, if things change quickly and break quickly, how do we kind of keep up with the implementations, right? Like, because there's, we've talked about it earlier, like every network is different and people might have needs for different things and different changes. How are you, like, this is like a question for you straight up, Rob, right? Like, how are you actually kind of managing these things where operators are trying to go in like different directions, and how can we actually bring that model to the ITF? Because everybody gets an equal say, but in open config, you can have a governance model where you can probably pick and choose what direction to go, right? Like, because it's not as, I would say, like, open as like ITF, if like, even though it says open, right? Like there's like a self-selecting group of people over there who can kind of determine like how things proceed. Do you have any ideas about that?
I don't want to sound facetious, but rough consensus and running code, but running code first. Like, I think the self-selection process in OpenConfig is actually like, will you write some Yang, or will you write a proto, or will you write a spec, right? And so it's in those scenarios, it kind of selects down to the folks that have a business problem to focus on, right? Like Google wouldn't have paid me for 8 years to be like run an open source project and have that external if it wasn't also delivering some business value for Google, right? And so I think that's part of the solution. But I do think the allergy to or the openness and maybe allergy to a bit more directional input is a big problem for all of this space, right? Because if we're going to have an architecture, that means you can't have a building. We designed a building and somebody just randomly adds a new story that's halfway up the building, right? Like there's got to be some way that you can say, well, no, that's not the direction this is going. And so we probably do have to figure out a way to have more governance that might look less open, but I think you can make it self-selection.
Perfect. Thank you. Thanks.
There's no one else in the queue.
I have one question for the audience. So we learned from Ian that Yang is a success. It's deployed. Do we have cases with actually people tried and failed?
Okay, I'll just add my own personal. I tried modeling multi-tenancy, an application that supported multi-tenancy using schema mount, and I just couldn't make it work. The tooling didn't exist to let it happen.
So it seemed that has some reaction. So next in queue is Rob, right?
Well, my comment's not based on that, so I don't know if you want to comment on that first. I was actually going to comment on looking back at some of what you've documented here. Some things I think that's maybe missing is a comment that was made maybe by Rob, is that the RFC of the standards are not the end goal here. So the need to actually understand that the goal is solving a business problem. So I think that's important. And I think the other thing that's also changed is I think ITIF has always been focused, and maybe Open Config is in some ways as well, is focused on solving the problem at one API layer. So what's the API between, for example, devices and the controllers? Whereas actually where we need to be looking at is solving these larger system-based problems. What's the end-to-end flow? What's the entire system and architecture look like? And what are all those pieces? And again, I think the stuff that Thomas has been doing, that's been good, where he's been trying to say, look, this is the business problem we're trying to solve, and this is all the pieces and how that works together.
Okay, Wim? Wim Hendricks, are you in queue?
Yeah. Yeah, I think so. I don't. Yeah. Yeah. So basically, my question to Ian. So I actually had a question to Ian, because when he said we've done the service model, my understanding is that this is typically done in Cisco NSO. Is that that was my first? Is that correct, Ian? Or
that's how we've been implementing so far.
Yeah. Yeah. And so my comment to that is that I think Cisco NSO and TLF, who started it, actually they built a really good system, right? Leveraging Yang all the way up. The issue that you have is that is a vendor-specific implementation, and you don't have others that come close, right? So that is the challenge that you see. So my background, when you asked the question, Benoit, did you try Yang and did you fail? My experience is the following. So I came also IETF, so Yang based, right? So what you do is, okay, you try to use and map Yang as data model, and you try to model everything with Yang, right? So the first challenge that you get is the tooling is very constrained, right? So I started to build tooling that basically helps map. So I'm also a bit of a fan of Kubernetes and using Kubernetes as that layer to help in the automation. So when I started building tooling that basically translates Yang, because Kubernetes is also open API based, you ask yourself the question, what are you doing? So a lot of people told me, okay, it's good, but we have a similar set of capabilities with all the tooling available, just use that, right? So as such, what you see is I try to use it, but you see that there is other ecosystems and other, let's say, implementations or protocols, or can you say that Open API is a full specification? I think so, which are not built by IETF, but you see that if you look at that developer ecosystem and the tooling around it and the amount of people that know it, that is the difference. And that's why you see, in my view, you have two challenges with Yang. One is you compete with that space, right? And second is that you have, let's say, you have then the challenge that some vendors do things a little bit differently and stuff like that, right? And also, I forgot to say is that the thing you compete with is a lot of it is open source. So you compete with a whole bunch of stuff that is open and to be consumable by everyone, right? I'm saying that I have to say that not all of these things are easily consumable and stuff like that. So we are trying to help in that space, right? But so that is also, it's not all shiny on the other side either, I have to say. But that's kind of a little bit the landscape that we are in, from my perspective.
Yeah, Wim participated in ANOG when I was there and shared similar comments, which captured and will be presented tomorrow as well. Holger, you're next in queue.
Yeah, regarding to Benoit's question, Luckily, we didn't really fail in production, but we did extensive testing before we introduced the Yang-based configuration in the network. And there were a lot of things. First, we had only one developer that was good at coding, understanding networks, and willing to learn Yang. This was the first hurdle that we had. Then we used the model. Then after half a year, we realized it doesn't do the job for new hardware, for example. We need to change that model. After that, when we were in production, we faced performance issues. We needed to optimize, so we switched all the models again and such stuff. So it wasn't really really hard after we started, but yeah, we're still, let's say, the first and only configuration system, or we have more than one configuration system, and there's only one using Yang currently.
All right. Any clarifying question there, Benoit? Were you able to capture the key takeaway?
I'm doing my best.
Okay. Thomas, you're next in queue.
Right. So for the question of an example where basically netconf and Yang was not working how it was being intended, I have one example from our production network where basically in some, let's say, major network operating system implementation, things worked very well. But in one particular implementation, similar as Holger already stated before, we were facing scalability performance issues. So at the end, basically, even though the config was very large on the device, and basically when the config is being parsed during boot up, if the config is written in CLI, it used to be the parsing of that configuration was basically done in a few seconds, while when written in Yang or being interpreted in Yang, the whole boot up process basically took about 20 minutes, and also basically during the interaction with the device, adding new configuration, it took quite some long time. So we really had performance and scalability issues, despite of the benefits of netconf and Yang being ACID, being declarative, and we had to actually roll back on CLI. And it's just like a minor vendor, it was a major vendor, and it's not at the year where basically the whole thing started with netconf Yang, it's already a few years down the road. So I was asking myself, like, what are we doing here?
A clarifying question. You said that when you're using CLI, it was fast, but with Yang, it took 20 minutes. Could you explain what is that at runtime or?
So that was just an example, like the boot up, when basically the initial config, the startup config is being parsed. But basically the same is also happening when you're incrementally updating the configuration compared to CLI. It took way too long time.
Okay, thank you. Rashad, you're next in queue.
Yeah, I just want to, I mean, similar response to what Holger and Thomas said to Benoit. What I want to add is people tend to find that the learning curve, you know, let's say if you're used to using CLI, some script which uses CLI, now you get an error, it's some cryptic, error message from a Mustoki statement in a netconf error, and you have to overlap that with, the Yang and all that. People at the beginning tend to find it pretty painful to use netconf and Yang. So it tends to be some specialized, a small number of people who have that specialty. That's it.
Interesting perspective. Christian?
Right. So, I mean, when we're talking about sort of, what we've tried and what failed, I think one is, this is more historic, right? So I've been working with, Cisco and so since it was tail of NCS, I've done interrupt testing with pretty much all the large vendor since very early days, beta builds of ISXR, et cetera, right? And I think in the early days, a lot of stuff was just broken. But this has over time become progressively much better. And today, most of the releases you get, it sort of just works, right? So it did, it did fail at some point, right? But the one thing, or one aspect of Yang that I think is a sort of failure, that is versioning. I mean, in Yang, as a data modeling language goes, right? We have versioning rules in the standard, and a lot of other data modeling languages don't actually care about this, right? They just specify like, this is what a data model looks like at this very instant in time, and they don't care about anything else. And I think in Yang, it was based on the idea that, a particular XML namespace, when we deserialize it, we should be able to say, yeah, this is this Yang model, and then we have to follow certain rules. We can't just change it and keep the same namespace, because then we break those backwards compatibility rules. And that's where, I mean, that's the sort of the idea behind this, right? Why we had them in the first place. But, and they were good. They were good because we could talk to vendors and say, here's a very official looking document saying that, you're not allowed to change things this way. In practice, that didn't do much, right? People did change. And I think if you look at the GitHub Yang models repo, you'll find that ISXR or Junos and many of these make backwards incompatible changes in pretty much every version, right? What's bad with the Yang versioning is that it just doesn't have the idea of something backwards breaking, right? And so this was a failure, I think. It just didn't work out in practice the way it was intended. And well, it would have been nice to do it differently. But hey, here we are.
So true. And something that's being addressed in the NetMod working group, the Yang versioning work there. Warren, I think you're next in queue.
Thanks. So yeah, responding to sort of Benoit's question, I mean, in addition to my day job, I volunteer with around 6 different networks, including a fairly large anti-spam vendor and the IETF NOC. And most of those networks have between sort of 15 and 50 devices. And I've tried NetConf multiple times. Sort of most of the networks I've been in have tried it a couple of times. And every time we've ended up just failing back to the previous sets of tools, including things like Libre NMS, Observium, Prometheus, Cacti, Nagios, etc. And this is not for lack of trying. I mean, for example, in the IETF NOC, we had Joe Clark, who's relatively well known in this community. And we just discovered things like, in one particular case, we were using Python with a bunch of libraries, and we upgraded Python 2 to Python 3. And of course, the libraries weren't available for Python 3, so we gave up. Or we couldn't find all the sets of models for all of the vendors. And so we had to have custom bits for different vendors. And also models would change suddenly without sort of backwards compatibility. And so because it's a bunch of different networks and most of them are sort of run on a shoestring, it just wasn't worth the amount of development time in order to do this. If it was a single network with, 300 devices, possibly, but for a large number of small operators, the amount of time and effort to build the system doesn't actually provide sort of the return on investment that's needed. But sorry, I realize that's probably not the message you wanted to hear.
I disagree. I think that's exactly the message we're wanting or needing to hear. Rob Walton, next in queue.
I don't think I was intending to still be in the queue.
Oh, it's an accident. You have a plus Q, maybe meant +1. Okay, in that case, Wes, you're next in queue.
Yeah, I guess one of my question takeaways for the day is, do we need one protocol? Do we need one modeling language? Is it actually okay to have more than one, right? Going back to my dog in the car, where I was arguing 20 years ago that we should really only have one. And to some extent, software was smaller there and machines were smaller. Maybe is something like NetConf and Yang great for the vendor-based applications that do want to do large-scale management across huge networks where that solution might just be fine, versus something else for local config and something else for monitoring. Is that an acceptable path forward, or should we really try and converge? And I'm not sure I have the answer.
Benoit, you're next in queue.
I'll answer that one, was so Yang had a lot of promises. However, Yang is not like the Uber data modeling language. There are different schema. You mentioned some for config, you mentioned some for monitoring. You know, if you got the PDU protocol like BMP or, you know, an IP fix, it's got this great schema. Why should everything be in Yang? So to me, it's a fact that we're going to have multiple schema in a network operation center. Let's not forget that, you know, you could invent a new routing protocol and get it deployed like SRv6 or Spring or whatever, SRMPLS in a couple of years. For the NOC, it doesn't work that way. The life cycle is way longer because you always need to manage all devices, right? Different vendors and all this. So to me, we're going to go in a world where there will be different schemas and with linked information.
Okay, Holger.
Thinking as an operator, normally what we do is we decide for the best way to go for us and then implement that, because we don't have resources to implement multiple protocols. And even if I look at vendors, if you think about multiple protocols for multiple stuff, they also have to implement that, all of that, and to maintain that. And I think this will end up in, we implement one or two of the protocols because we can't do more. We don't have the resource for that. And as an operator, I would choose one of them just because of resources.
Resources, the common comment here. Rob, you're next in queue.
Yeah, I think to weigh in on that thought, we should think about where the APIs have lots of cost to implement different versions of them, right? So like you probably don't want a million flowers blooming across interfaces that require both vendors and operators to implement, because then you have versioning issues. You have to solve all of those problems, all the problems in each of the interfaces. But I do think we should think about, and that doesn't mean there needs to be one. It means there just needs to be a smaller number. But we should think about where some of these applications are just private APIs, right? Like using Yang for service modeling doesn't make a lot of sense to me. It's kind of like pretty bad ecosystem generally. It's got complex ways to express different data types, which doesn't really make a huge amount of sense. It doesn't look like the best fit for the job. But that's fine, right? I can make that decision in my software stack, and it doesn't impact anyone else because that API is entirely within my company. It's entirely within my network management stack. And so in those cases, there is a lot more room to try and make, to leave room for many different solutions. And if we distract ourselves by trying to get there to be one true way to do the same thing everywhere without looking at the business value of doing that, then that's just distractions. It's just going to mean chasing millions of different features that are different for every operator.
Okay, great, thanks. We are coming close to our time limit. Torles, you're next in queue.
Yeah, maybe from the IETF side, right? So not solving all the operator problems, but hopefully towards making our standards more usable, right? And that is, we really need to think about an information model that's more lightweight to add to, standardized protocols, so that we know what knobs need to be configurable in what way, and what parameters need to be observable without going the whole way into Yang. And with such an information model step, it would hopefully be easier for different communities to choose the data models to use, if not Yang.
Okay, great, thanks. And last queue item, a person in the queue, Christian.
Right. So, I mean, on this whole sort of a single protocol or unify or whatever, I think to some degree, being these protocols or in the Yang ecosystem, right, we have many model-driven protocols. So I think that, we're already sort of at the point where, you can write some Yang model configuration and we can easily convert them between XML, JSON, or CBAR. So, I think that these, as far as protocols go, there's no real need to sort of unify on that and find the one true protocol. You can quite easily use all of these in the Yang ecosystem. When it comes to outside things, sure, in some situations, yeah, it's just better to use something else, right? I think that as far as service models goes, what was really nice is the concepts that Jürgen brought up, right? The declarative, composable, and I mean, so when you adhere to those, that's really powerful. But when you have a management stack, right, where we're doing declarative netconf or GNMI or RESTconf, doesn't matter, right? They're all Yang model-driven transports. We're doing that southbound, and then on top of that, we put something that is of an entirely different paradigm, right? If it's based on RPCs, like, hey, go configure this little thing, or hey, do this other thing, right? Then we get that sort of impedance mismatch, and that's really painful. So aligning or unifying on the paradigm of declarative and composable configuration, that I think is a very good thing. And we should strive to raise this in our stack, right? It's not just for device management, but higher up.
Okay, thank you. That was a nice concluding comment. All right, so as session one chair, along with Benoit, we thank everybody for joining. It was a good discussion. It was a difficult discussion to speak about the past. I think so much of us want to speak about the present, but we did what we could to capture that, and so thank you for that, all of your comments. And so unless Benoit wishes to say something, maybe we'll pass it to the workshop chairs if they have any closing comments.
Benoit, thanks Kent for organizing this discussion. It's very important. Folks, for tomorrow, please be ready with the feedback that we want to capture in our final key takeaways for the session one. And for session two, we are focusing on the requirements. So please do look at those new requirements and be ready with your feedback. The notes page is available. You are free to edit them afterwards as well. So looking forward for next 2 days of more discussions, and please use the mailing list if some of the discussions need more further discussion. We have a mailing list. We can continue the conversation there. Otherwise, we will all see you tomorrow. Thank you.
Great. Thanks. Bye, everybody.
Thank you all for coming. This was a good discussion.
Thank you all. Bye. Very nice. Nice seeing you.